Sometimes you'll be asked to factorise things that look like this, or you'll be asked to solve for x by factorising these things. Now, if you're asked to factorise something, well, and it looks like you can't, because these two both look pretty weird. Basically, if we're asked to factorise, we're asking, well, the factors of this, c, so of -1, that add to make 3. Not going to happen, because the only things that multiply to make -1 is -1 and 1, and they're not going to add to make 3. Likewise over here. 53, it's a prime number. And so no factors of 53 can add up to 12, or even -53 can add up to 12. So what we do is we can try this thing called completing the square. So to complete the square, what we do is we take our thing of ax squared plus bx plus c, and we rewrite that as ax squared plus bx plus b over 2 squared minus b over 2 squared plus c. So what we're doing is that we are adding something and we're taking that away. But that only works if a is 1. If a is not 1, we've got to take that out as a common factor. So we'll have a look at that soon. As well as that, you've then got to apply this thing. The a squared minus b squared equals a plus b, a minus b. And we'll also have a look at that as well later on, but that's if we're factorising. So we can complete the square to either find a turning point, and we go a little bit further and we can factorise. So let's see this thing in action. Now we've got x squared plus 3x minus 1. So what we want to do is rewrite this as x squared plus 3x plus 3 over 2, oops, let's write that clearer, 3 over 2 all squared minus 3 over 2 all squared minus 1. So then we'll rewrite, so now what we want to do, we want to factorise this here. And to factorise that, that'll end up becoming x plus, because they're both plus, or rather because this one's plus, 3 over 2, and we're going to say squared. And that's the way we do it. And then over here we'll have minus 3 over 2 squared minus 1. Next step, x plus 3 over 2 squared minus 3 over 2 minus 2 over 2. Next line, x plus 3 over 2 all squared minus 5 over 2. So that's what we've got. Hang on, that's not 5 over 2 and 3 over 2. Backtrack a little bit here. We've got to square it. We square that, so it becomes 9 over 4, and we want to write this as a fraction over 4, so 4 over 4. So then from there we've got x plus 3 over 2 squared minus 13 over 4. Okay, so then if we were to stop here, this would be our turning point. Our turning point coordinates would be -3 on 2 and -13 on 4. But we're factorising, and when we're factorising, hopefully I can move this out of the way. Nope. What we're trying to do when we factorise is we want to make our final thing here look like this, and it's close. It's not far away. But what we want to do, we want to write this a squared minus b squared thing. Right now we've got an a, and we're squaring it, and we've got a minus, we've got something else. But the problem is we want to turn this into something we can square. So to turn this into something we square, we've got to do the opposite of square, which is to find the square root. And we just write that as being the square root of what we've got there. So we're going to write x plus 3 over 2 all squared minus the square root of 13 over 4 all squared. And now we've got a squared and we've got b squared. A squared, this is a squared, and this is b squared. So that's what we do. So now we apply this rule here. So I'm just going to rub some of this out here. I'm not rubbing out, I'm just going to cover it up with a square box. It's like having an eraser. Okay, so from there, what we're going to do is we're going to apply the rule of a squared minus b squared equals a plus b, a minus b. So that's a, so we'll say x plus 3 over 2. Now we're going to say, and that's our, this is b, we're going to say plus b, so we'll say plus root 13 over 4, bracket, 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 and we'll say, now we're doing a minus b, so x plus 3 over 2 minus root 13 over 4. And of course we need to simplify that even further by turning this into root 13 over 2. So x plus 3 over 2 plus root 13 over 2, x plus 3 over 2 minus root 13 over 2. And that's it. Okay, let's see it in action for a second time. So we've got this thing here. So what we're going to do, we're going to halve this and square it, and that's what we're working with. So x squared plus 12x plus 12 over 2 all squared minus 12 over 2 all squared minus 53. So from there we'll have x squared plus 12x plus 6 squared, because we can simplify that squared, minus 6 squared minus 53. We factorise this, x plus 6 all squared minus 36 minus 53, which is minus 89. So now from there, that's our turning point, negative 6 and negative 89, but we want to factorise further, we want to fully factorise that. So we'll x plus 6 all squared minus the square root of 89 all squared. So here is a and here is b. A squared minus b squared, a plus b, a minus b. So we'll say x plus 6 plus the square root of 89, x plus 6 minus the square root of 89. So that is how we fully factorise something where we can't automatically find factors of that. So we start with our equation, whatever it is, we rewrite x squared and 3x, x squared, so we rewrite the first two terms, and then whatever this term is, halve it and square it, take away, halve it and square it, and we put in our c term. So likewise over here, it's on 3 over 2 squared, 3 over 2 squared. Over here, 12 over 2 squared, 12 over 2 squared. And then we simplify this to turn it into this. If it's a fraction, we can just leave it as a fraction like we did here, and we just put that in there with the x, and that's how we factorise that. And then everything else is the leftovers. And once again, once we reach this point, that's your turning point form, that's your turning point form, tells you where the turning point is, but then you've got to go one step further and take the square root of the constant and square it so that it is written in the form of a squared minus b squared, so that you can apply a plus b, a minus b. And that's how we complete the square to factorise.